This is the DFRobot Microenvironmental Module, and on this project I'm monitoring 7 environmental parameters. So these include the temperature, pressure and humidity, and that's using a BME 280 module. I'm also measuring ultraviolet radiation, sound and light, and the carbon dioxide level. A microbit computer is being used together with Microsoft Makecode, and the program collects the data and it displays it on this LCD every minute, so it's updated. And the data logging is done by a software real-time module. So everything's connected to the internet, and it uses a Wi-Fi. And the Wi-Fi light, when it pairs with my Wi-Fi AP and home network, here it shows that it's connected to not only that, but to the internet. And it's connected also to a MQTT server in Shanghai, China. We'll have a look at that in a minute. So if we want to interact with Microsoft Excel, we not only update the display on the LCD, but we also transmit the data by web USB. And we can send the header by pressing button A, and that becomes the title for our Excel spreadsheet, which we're doing right now. So the ultraviolet radiation calculates, is sensed, and a ultraviolet index from 0 to 15 is calculated. If the and from that, the color code for the ultraviolet index from green to violet is shown on the array of LEDs, which is connected to port 15 on microbit. So you can see the color change. At the moment, since we're indoors, we're not really using the color for the UVI index only. We're also using the color as a feedback when we get messages returned from topics 0 and topic 1 from the MQTT server. So let's have a look at some of the software on that. And over here we have the microbit on the Microsoft Makecode software, and it's in a web USB configuration. So it's now monitoring the communications over USB from the microbit. And if we go to the data that we're collecting, we'll have a look at the spreadsheet. And that data over web USB is collected by the PC, and it formats it so that it's suitable for Excel. So here you can see on the left column we're plotting the minutes and hours together with the environmental parameters of TB, T for temperature, H humidity, B pressure, and they're all coming from the BME 280. Next to that, we're collecting data from the light, the sound, carbon dioxide level, UVI, and the timestamp from the real-time clock. And all of that goes to the goes to the chart and plots all those parameters. Now, having a look at the software, before we look at the software, this is the site, Easy IoT, and the topic 0 parameter is being shown here. These are the topics: temperature, humidity, pressure, light, and carbon dioxide. And I am limited to 5 parameters. So if I wanted to see the messages that are coming from that are going from my software to the website, you can see them here. I'm monitoring the temperature, and at the moment it's 15.1 degrees. Now we can have a look at the code that's driving all this, and here it is here. And I'm using a couple of extensions to the Makecode. The first one is the Environmental Science, and we have a look at some of the modules that are there, and you can see that I'm using almost quite a number of these: the OLED, the RGB, the IoT. So they're all being used. The other modules that I'm using come from a software real-time clock, and this has been used to set the time, but also to provide a stamp and an event. So every time the minutes change, it starts a sequence of data logging operations. And to have a look at that software, we just expand, we can see the whole of the software. And on the left is the startup routine. And you can see there's nothing happening in the forever loop. So almost everything has been event driven. And you can see the event driven program here. When the minutes change, it gets the results, initializes the LCD, and logs the results. And then it's sending the message to the MQTT server, logging for topic 0, temperature, for topic 1, humidity, and topic 2, pressure, followed by light and then carbon dioxide. And we used up all of our 5 topics to that server. And here you can see the other functions that are being used. Here, get the results is collecting the data that we just mentioned on temperature, humidity, pressure, and setting those to variables. The last one you can see there is calculating the UV index. So it's mapping the analog value from 0 to 2023, the maximum, and that corresponds from 0 to 15, which is the UI index scale. So here's how we initialize the LCD on the unit. And when we press the buttons, the only effect they have is to send a message, send the call message. And all that does is sends over web USB the header for our Excel spreadsheet. And here you can see what happens when we log the results. The first group of parameters is logging that onto the OLED display. Then we log the parameters on the web USB. And finally, we log the result onto the NeoPixel array, depending on the UI, the ultraviolet index, and the color is selected by this logic. And that's it. This is the DFRobot Micro Environmental Science Unit, and that's it for me for the time being.